right, guys, so this is not in our student journal, like I said, but this is over section 5.6. And these are some concepts that I think are a little confusing about inverses. So we're going to kind of be proactive about this before you get your review paper. And we're going to talk about how we find inverses for these kind of problems. All right, this first one, very similar to our warm-ups. We know this is really y, so we switch y to x. We switch x to y. We solve this. We divide by 2. And so now I've got this. Before I go any further, though, I want to think about the domain and range of this original function. The domain of this original function would be negative infinity to infinity. I can use anything. What would the range of this function be? Right. So if the domain is negative infinity to infinity of this one, the range of my resulting function should be negative infinity to infinity. If the range of this original function is negative 3 to infinity, that's what the domain should be. Because these are x's, these are y's. Y's become x, x become y. So I'm going to finish solving this now, keeping this in mind. So I take the square root. And the question was earlier, do we put plus or minus in front of here? Well, if the domain has to be negative infinity to infinity, then down here the range needs to be negative infinity to infinity, and the domain must be negative 3 to infinity. If I leave it without putting plus or minus, is the range going to be negative infinity to infinity? No. That's why I have to put plus or minus. And see, you can think about what the graph looks like to know that. If I had just put it in, and watch how I put this in because people always put this in incorrectly. I'm doing the square root of parentheses x plus 3 divided by 2. All of that's under the radical. If I just put that in the way it's given, is that range, or I'm sorry, yeah, range, is that range negative infinity to infinity? No. But if I go down here and I put in negative, see the whole x plus 3 is getting divided by 2, and now I graph it. See how now the range is negative infinity to infinity? Is this resulting inverse, is it a function? No, it doesn't pass the vertical line test, does it? So this is the way I would write my answer then. The inverse of f of x is plus or minus the square root of x plus 3 over 2. Would you recognize that this means the same thing? I didn't mean to extend that down. How did I get this answer here? What did I do? Can you see all I did was rationalize the denominator? This is over radical 2, so I multiply the bottom by radical 2 and the top by radical 2, and that would be another way of writing that answer. Okay, rationalized. Okay. All right, let's go to this one now. So we're going to start off. Domain, what is it? It's our square root function. Looks like that. Shifted 3 units right. Looks like that. What's the domain? 3 to infinity. We're not allowed to have negatives under the radical. Here's the way it looks. What's the range of it? Range, guys? 0 to infinity, isn't it? All right, so now I'm going to find the inverse. This is my y, it becomes x. This is my x, it becomes y. I'm going to square both sides. I'm going to add 3. Now, here's what I get for my inverse function. But what does this function look like? You should know that function. Do you know what it looks like? What kind of shape is it? It's a parabola, right? Look, I'm going to go ahead and graph it. It's not upside down. Here's my original function. Here's what we're saying the inverse is. Remember, the inverse has to be a reflection over the line y equals x. Is this a reflection over the line y equals x? No. Plus, look back here. Whatever our domain was here is what our range has to be. Well, that's okay. That is our range. But whatever our range was here is what our domain has to be. So what do I have to state that the domain has to be? After this answer, I would have to say that x must be greater than or equal to 0. Because look, I can go back to this function and I can say divide this up and only graph it when x is, and I go under test. Now I'm telling it only graph this function if x is greater than or equal to 0. Now look what happens. I'm not sure what happened. Hold on. Oh, I put it in the wrong spot, didn't I? Down here is where I want it. So divide it up. Only graph this when x is. And now look. Here's my original. Okay, let me try that again. This is being picky. I know what it wants now. It wants this all in parentheses. The other version of the calculator didn't care if it was in parentheses, but this one does. Okay, so finally, here's our original, and here's our inverse. See how now it does work as long as I make that restriction? Yeah. I can, sure, zoom square would be zoom 5. And now it's going to look even better with that inverse. Okay? Yeah. Yeah. Okay, the reason why, the calculator doesn't have great notation for this. Like, to me, I would love it if they had an actual semicolon. That would make more sense. But because there is no semicolon on here, the calculator developers decided to have it say divide the function up, and that tells it when to graph the function. So I could change this, and I could say only graph it if x is greater than or equal to whatever number I want. I could say 4. It doesn't make sense for this problem, but look what would happen. Now it's only going to graph that function for the x values that are greater than 4, which aren't showing up, because if you think about that, that would be 16, which would be off my graph. Okay, maybe I should make it, let me just make it 1. So see how 1, now it's only graphing it if x is greater than 1. Okay. So we haven't done much with that, but that's a way to make it graph only part of the function. Okay, so anyway, back to this. This would be the way we should write this answer. This is our inverse, but we only graph it when x is greater than or equal to 0 to make it the inverse of that. Okay? All right, down here. So this one is telling me that to start with, this is our function. So we're graphing x squared minus 3. Here's what that looks like. I'm only graphing it when x is greater than or equal to 0. That's my domain, my stated domain. What's the range, guys? -3 to infinity, right? Here, I'm going to go ahead and find my inverse. My y becomes x, my x becomes y. I'm going to solve this. Take the square root of both sides. So the question is, do I really use plus or minus on this one? Why not, Maren? Right. This function is going to be a shift to the left 3 units, and it's a square root function. It looks like this. If I have the plus and the minus, it's going to look like this and like that. That's not what we want. We only want it to look like this to be an inverse, so I get rid of the negative on this case. Also, look at the domain. The domain was x is greater than or equal to 0. So on this one, it means that our range must be from 0 to infinity. And so for this problem, the inverse is going to be that instead of plus or minus that. Do you see the difference? Back here, bless you, back here I had to use the plus or minus because the range, the domain back here was negative infinity to infinity, so my resulting range had to be negative infinity to infinity, so I needed the plus or minus. All right, and this last one's going to seem easy after all of that. So this is why it turns, of the new one, same as the range of this one. So the domain would be negative 3 to infinity. And that should make sense. Remember how we don't want to have any negatives under the radical? So it makes sense that that would be the domain. Yep, 0 to infinity. All right, so on to this one now. Here's my y, it becomes x. Here's my x, it becomes y. So to find my inverse, I now have to take the cube root. If I take the cube root, do I put plus or minus in front of it? No, because if I'm solving a problem like this, x cubed equals 27, could the answer be negative 3? Would negative 3 cubed be 27? No, it would be negative 27. So that's why if I take a cube root, I don't have to put plus or minus. So this inverse then is just going to be the cube root of x minus 1. I check this domain. This domain is negative infinity to infinity. This range is negative infinity to infinity. Because here's what a cubic function looks like, right? And so this is my inverse function. And watch, you can even look at these and you can see that they're inverses. This is what I do sometimes. If I've done a problem and I'm not sure if I did that inverse correct, then I just graph it and I look to see if it appears to be a reflection over the axis. So, not the axis, but the line y equals x. Here's the original function and here's the inverse function. Doesn't it appear to be a reflection over the line y equals x? So therefore I know that it is. Yes. Another way I can double check is to see if f of f to the negative 1 of x, to see if that equals x. That was another way to check. So what that means is I take my inverse function and I plug it into this x. So my inverse function was this. I plug that in for x, it's going to get cubed, and then I'm going to add 1. So if I have the cube root of something cubed, that's just going to be this, and I get x. And so that proves that that is the correct inverse. Okay? Lots of good stuff there with inverses. Any questions? All right.